You'll be writing a quiz on this stuff in the next day or two, so no hands. That means it'll be real fun when I mark it. 12 on 156. Computer's frozen. Close window, open window. So sketch the graph. What would be down here? Time. What would be over here?
Number of cartons.
Cartons. So, 100 cartons at 7 a.m. It is 3/4 full. So what is 0 time? What time is it here?
12 o'clock. Isn't it? Oh, it's 12. It's 12.
7 a.m. would be a great way to start. But you don't have to. It's just one way to do it. 25, 50, 75, 100. At 7 a.m., there's 75. No cartons are sold from 7 to 8. So what happens to this line? Stays straight. No cartons are sold. It doesn't change. 8, 9, 10, 11, 12. 1, 2, 3, 4, 5. Because after 5 p.m., nothing's sold. 8 to 10, 10:15 to noon, and 1 to 3, students are in class. So, what should happen between 8 to 10? It should be nothing, because students shouldn't be going to buy juice. But let's pretend this vending machine is an Abbey Senior. So, what happens from 8 to 10 a.m.? The juice goes down because people are going to buy juice. By a lot or a little? A little? Okay, so that's 8, 9, 10. Here's 10. Maybe it goes down a little bit. What happens 10 to 10:15? Are kids in class? So what's going to happen? It's going to drop down a little bit more for a very little amount of time. Then what? 7, 8, 9, 10, 11. There's 12 noon. 10:15 to noon, they're in class, so it's going to maybe go down a little bit more. Except what happens at 11? To where?
100?
Back up to 100, right? So very steep up to 100, because it takes time to fill. Then what? It's going to level out probably till noon. What's going to happen at noon?
It drops a bunch.
Big drop. Till when? 1. Then what? Level-ish until 3. What about 3 o'clock? This class is over. What happens?
It stops.
It's going to drop more until 4 o'clock. What happens at 4?
It is refilled.
Refilled. That's what the graph should look like. Something like that. As long as you have a couple of peaks and the flat line, you would get full marks. Because none of this is this. Everything highlighted in yellow is conjecture, right? You have no idea what is actually happening there. The only stuff you know is nothing is sold from 7 to 8, so the line is flat, and you know it's filled twice, so it's got to go back up to 100, right? If it was filled with what's a gross juice? Grape. Blech. If it was filled with grape juice, probably not too steep. Okay? Grape pop is even worse than grape juice. Any other questions?
Banana juice.
Any other questions? Dan? 18? Okay, we want to graph these, yes? So it says to use the same graph, right? So what are the two parts of the graph going to be? What's going to be down here? Time, like always. What's going to be here?
The amount of water.
Depth. I'm going to do this one with a red line, this one with a blue line. So, at 0, 0, with my blue line, so this, no, we'll do red line first. 0, 0, how full's the pool?
Nothing.
0. Water goes in, what happens? It goes up, right? At what? Constant rate? Is somebody up at the top turning the water on and off, higher, lower, do you think?
No.
No, so it's a constant rate, so it's going to be a straight line, yes?
Yes.
Okay. And as time goes on, that's going to go up, yes? So describe to me what it's going to look like until then. It's going to be a nice straight line, yes? What happens when it hits there? What does that mean that's slow down? It's going to flatten out. Why, Zach? Because now the water's got to fill all the way over to here. So, does that look like about double? So it should be half as steep as this, yes? Everybody happy? I filled up just as much depth, but in double the time. Everybody cool? Okay, what about the blue line? What's different?
There's a slant, so it
This.
fill up the same.
So it's not going to fill up it's not going to be as steep as this, is it? How's it going to start? Is it going to start steeper or shallower than this?
Shallow. Well,
Steeper. Why? Because I'm filling up much less. Right? But then, it's going to meet up right there, isn't it? At the same depth. But it went further this way, so it's going to take more or less time.
less.
Less time? More time. So I get to the same depth in more time. But then what happens? Is the blue line going to be steeper or shallower once I get to this point? Steeper, because it's not as much to fill. But it's still going to end at the same depth, isn't it? Okay? What's next? Why don't I do 16? Chad goes bungee jumping. The distance above the ground as a function of time. What's down here?
Time.
Time. What's here? So what's the word we like for distance above the ground? Height. At 0 time, is he on the ground or above the ground? Above the ground. As time goes on, what happens to his height? He jumps, so it goes down. He's jumping off something. His height goes down. Steep or shallow?
Steep.
Steep? Does it change or is it constant?
Constant.
Constant till when?
It hits the ground.
No.
Until the
Till the bungee cord starts to stretch. Then what will happen to his speed?
Goes
It will decrease slowly. So he's going to go down fast, and then he's going to start to slow down, cover less height in more time. Then what happens when he's at the bottom? Toby. His height's going to go back up. Is it going to start going up fast?
Yeah.
Yeah. So it's going to be what? Sharply up. And then what's going to happen? He's going to start slowing down. Is he going to get all the way back up to the bridge? Of course not. Then what? Down steep. And then what? Curves and slows up. Then what?
Goes back up.
Back up. Does he go as high as this one?
Nope.
No. Up steep curve. Everybody good? Excellent. Okay. Now, change to speed and time. How fast is he going at the beginning of the jump?
Fast.
Really?
Oh no, he's not moving.
He's not moving. Oh, he's standing still going, I can't believe I signed up to do this. I paid someone $120 to jump off a bridge. So what's his speed? 0. What happens when he jumps? It goes up really, really fast. And then what?
It goes down really fast.
It starts to slow down. And technically, what's his speed at full stretch? 0, right? So his speed goes way, 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 way up. So is this right? And that's not quite right, because it's got to go up, 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 and then he starts to slow down, 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 to 0, technically. Then what? Up. Because the thing snaps him backwards. Up, 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 0, 0, 0, 0, 0, 0, 0, 0. It's just the opposite curve. Because they are not drawings of what is happening in real life. Anything else? What did they say in the answers for that? I'm curious.
I think it said it's like can be missed.
Answers may vary, so yeah. Yeah. That's what we did. Curve down to 0, less high, less high, less high. Down to low, less high, less high. I mean, I was wondering if they gave an answer for the explanation for the B part, but they didn't. Anything else? Ready to go on? All right. Turn to page 163. Let's make us a graph. What goes on the bottom? Time. Is that all we need to label down there? The unit of time. What is it?
Days.
Days. Yay. Is that all we need to label down there? What else?
The numbers.
The numbers. 1, 2, 3. How far do I have to go with these numbers?
7.
Why?
Because there's maximum 7 days.
Because it says right in the question, I only have data up to 7 days. What goes on the left?
Money, like budget,
Cost. In what unit? Dollars. And I'm going to go up by 50s. Okay, everybody agree? Let's do some graphing. Where's the first dot go? Time 0, obviously. That would be down here. I walk in the door, I want to rent a car. Okay, sir, give me some money. I will. How much? $65 per day. So I got to put my first dot at 65, right? Everybody happy with that? Do I need an open or a closed dot there? Closed?
No, open.
I walk in there and I don't rent a car and the guy takes $65 from me? So open or closed? Open. How long will it cost me $65 to rent this car? Nope. Read the question. For the first 3 days, so how long does that line go out?
7.
Per day for the first 3 days. 65 per day for the first 3 days.
So it goes to 3.
It goes straight for how long? No. 65 per day for the first 3 days. How long does this line go? 1 day. Open or close dot?
Closed, because it's
Closed, because I only rented it for 1 day. And that, because we're just sketching the graph, I'm going to write 65 there. Everybody cool? So we can see. What happens if I'm having so much fun with this car, I decide to keep it a second day? I go 65 more dollars. 65 per day. So it goes up to what? 130. Open or close dot? Open. Because I paid for 1 day. I don't pay more until I go past 1 day. So this line goes all the way across till when? 2. Open or close dot? Close dot. And that's 130. What happens if I want to keep it a third day? I go up to 195, just below 200. Open or close dot? Open. 195. Does everybody understand so far? Great. What happens now? I only go up by 30. So what's the next one? 225. Open or close dot? Then what?
Is that on the floor? Okay.
Then what? 255. Then what? Then what? Does everybody agree that that explains my graph? Or my data? The graph explains the data. Everyone's on board? Okay. Should the points be connected? Weird question. Lots of points on this graph, yes? What are our options? I could connect all these closed dots, right? That's one option. What's the second option? I could connect all the open ones. Which one of those makes possible sense? Closed dots. Why not the open ones? They're open for a reason. They don't exist. Okay? And the fourth option would be this. Or the third option.
That's what I thought I did.
What's wrong with that option?
He's going up more money if he's at the closed down.
Is there anything wrong with that option? Talk to your neighbors. Decide, first of all, yes or no. And then a reason.
So that means he's making money when it's the end of the day.
So the first word here should be yes or no, and then a reason. Alrighty, how many people are yesies? One of those options. Yes. How many people are yes? Be proud. 1, 2, 3, 4, 5. 5. How many are no's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Hey, it's just like a Canadian election. Only 16 people voted when there should have been 30. Huh. Kinda. I'm just talking about piss poor election turnout in general, right? Everybody complains about the government, but over half the people don't vote. That's kind of like saying, I really hate McDonald's food. I'm going to keep going there. McDonald's food's making me fat. Give me another Big Mac. But whatever. Yeah. I'm going to quit smoking. I better go and buy a carton.
Yeah.
Right? Or the climate is being ruined. Let's make sure we find more efficient ways to burn fossil fuels. Never mind.
That is actually a thing.
Of course it is. Why do you think we're trying to build pipelines?
To
To move oil around. Why do we want to move oil around?
reduce.
To make money. What will that making money do to our planet? Ruin it. So will all the money in the world be worth anything? No.
In my 2050,
Right? If you're going to spend $20 billion on how to move oil, don't you think it would make more sense to spend $20 million on a better way to get energy that isn't going to destroy the world? Yeah. No such thing as climate change. Ask Donald Trump. He knows everything.
Right in front of his eyes. He's so
All right. So, the answer is, of course, no.
because
Here's why. If I connect, first of all, we've already talked about why we can't connect the closed line, the open dots, right? Okay. If I connect this line and I rent the car for 1.5 days, here's 1.5, agreed? So I go up and, hey, wait a minute, that's not 130. Is it? 130 is up here. So if I have this line here, that point of 1.5 and then halfway between 65 and 130, which would be 32.5, 97.50 would exist, wouldn't it? Does that point exist? No. So I can't have the line through the closed dots. All right, Mr. Myers, wise ass. Why can't I have that line? Can I ever have a vertical line on a time graph? Why not?
time doesn't stop.
Time doesn't stop. Everybody with me? So, connect the lines? No. Why not? Because there are output values that don't exist. And that's this line right here. I'm going to highlight don't exist. Input 1.5. If that line is there, the output should be what? 97.50, right? Halfway between these two. But it isn't, is it? Because I can only pay 65 or 130. Everybody good? Everyone's okay? All right. Next, is it a function? Ooh, tricky. Again, yes or no. Take a moment, talk to your neighbor.
Just two dots.
No. There was a teacher drumline a few years ago. I was going to it. It stopped. I did. I like all forms of music, even though I'm a talentless lump.
Your talent is math and surfing.
All right.
A relation.
Function, yes or no?
No.
Yes. What happens right here? That dot doesn't exist.
Oh.
It is a function. So, it appears yucky, but in reality, it is a function Because
It's not a yes or no question.
every input, what are the inputs? Days or cost? Days. Every input, every day, gets you what? A different and unique output, which is what? Cost. If I say any number between 0 and 7, can you tell me how much it will cost me? 2.3 days, how much?
195.
195. 20 minutes. 65. 6.5 days.
350. Or
315. 5 days and 20 seconds.
285.
285. Everybody understand?
Is that a yes or no? Because
Is this relation a function? Yes. Because anytime you put two things compared together, you have a relation.
I thought I was asking, is this a relation or a function?
No. Is everybody good with why this is a function? No matter what my input is, I get a different output. Yeah? Okay. Now, what is the domain and range? Domain is what? Holly? Always? So give me a better definition. Domain is the set of data in the independent variable, which lives usually where, Holly? On the x-axis. But it doesn't have to, because for looks, I might turn it around. Right? You can. Everybody cool?
Yeah.
I mean, how many of you guys have seen a graph that looks like this?
The starting
Right?
of the
For example, how many books you've read. What's the independent variable? The books that you read? The books depends on you? You read the books. So if I put Myers here and 7,000 here, isn't this the x-axis? But the books don't depend on me. I depend on the
It's
books.
on the y-axis.
Do I?
It's
I don't depend on the books.
flipped.
There's 10,000 books in the library. Does that mean I've read them all? No. The books, amount of books read depends on me. So even though Myers, my name, is on the y-axis, I'm still the independent variable. So I'm still part of the domain. Looks change it. Okay? So that's why I said usually. So back over here. What's the domain?
The time.
Okay, the time is the domain. We agree. In this case, and it is on the x-axis. What is the lowest value that I will get an output for?
1.
No.
0.
No. I will not.
Oh yeah, it has to be like just right as you go.
Right. So 0, but I will never hit 0 because there is no output for 0, is there?
Yeah.
So what goes here? X?
Time.
I would say time or days. One of the two. Or you could write days. And it goes up to what? Does it include 7?
Yes.
Does it? Can I rent this car for 7 days?
No.
Up to 7 days.
Yeah, but it's
At the 8th day, once I go past 7, this deal is off. So is 7 included? Yes. Now, Zach, read us your fun way. Soft bracket.
0, 7, hard bracket.
Everybody cool? All right. What's the range? It's tricky.
It is 60. No, not 65. I forgot.
Range is the cost.
No soft brackets. Can't have brackets. Why? Because it goes up how, Holly? Step by step by step. There is only 7 values here. So it's 65, 130, 195, 225, 255, 285, 315. And that's all it can be, because it can't be anything between any of those numbers. Okay? Everybody cool? All right, now, without me explaining it, I got two new words here. Discrete data and continuous data. What do you think those words mean? Because I haven't explained it to you.
Discrete means
It's a different kind of discrete. But that's okay.
Discrete that stops, like it's
Now, if you mean discretion,
I don't know about you, but your viewers' discretion
that's
is
what I just
advised.
I use discretion when I tell you guys stories about what I do on the weekend. What do you think that means? I don't tell you everything that goes on in my weekend. Right? Because there's 48 hours in there. If I were to tell you everything that went on in my weekend, it would take more than the class. Right? So that is using discretion. Right? Discrete, discretion. So, and continuous, what does continuous mean?
it just keeps going.
Just keeps going and 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 going. Okay? Everybody cool? What do you think we have here? Holly. Excellent. So, our graph we have here. Over the course of its domain, do you think it is discrete or continuous?
what's continuous, I think.
So Moret says it's discrete because why, Moret? Yeah, okay. So that's why I added that little bit of a addition, right? Over our domain, because that's the only data we have. Is the data within our domain discrete or continuous? Do you still think it's discrete? Joseph, you think it's continuous. Why?
Because it goes over like a span. It's here to here, and in between it's just like a slope kind of thing. Yeah.
Okay. Can we refine that a little bit? Because that didn't sound very mathy to me. It goes from here to here with a little slanty thing.
The days, like you go through the days.
You go through the days, which are what?
Time.
Inputs or outputs?
There.
Independent variable or dependent? Use some math words.
Independent.
Okay. For every independent variable, is there a dependent variable?
Yes.
For every input, is there an output?
Yes.
So is it continuous?
Yeah.
If I say any input value from our domain, is there an output?
Yes.
So is it continuous?
Yes.
Okay. So would it be fair to say then that continuous data has an output for every input? Are you happy with that definition? We've just talked about it. Are you happy with that definition? Is that fair? If I say an input value and there's an output for every possible value. Let me give you an example. I rent the car for 1 second. Do I pay $65? Yep. I rent the car for 30 seconds, so I pay $65.
Yeah.
Rent the car for 90 seconds, so I pay $65.
Yeah.
So is it continuous? For every possible time from 0 to 7, is there an output?
Yes.
So are we happy with that being continuous?
Yeah.
Okay. So what then must discrete mean, according to your guys' definition? Talk about it amongst yourselves. Talk about it amongst yourselves. Find a way. What do you think? We've already discussed continuous data, yes? What is it? Let's break it down even smaller. Is the domain continuous?
Yes.
Why?
Because for every input there's an
For the domain, I can pick any number, can't I?
Yeah.
0.00001 of a day all the way up to 7 days.
Yeah.
So the domain, we're all cool with being continuous, yes? Is the range. Why not?
Because you can't pick any number. You can only pick
I can't pick any number. I only have a select few, yes? Everybody cool?
Yeah.
All right. So, discrete data is any data that is restricted to certain values. Okay? Everybody understand? Another way I could say it. Sorry, Hannah, what? Is it too tiny? All right. Any data that is restricted to certain values. Another way to say it, discrete data is counted. Let me give you an example. Students in this class. Is that a function or a relation yet? No, because it's only one piece of data, yes? I haven't related it to another thing. Would students in this class be discrete or continuous? Discrete. Why? Can't have half a person. I can count you. Yes? So it is discrete. What is my height? Is my height continuous or discrete? Continuous. Why?
because you're not chopped up.
I'm not chopped up into little pieces. Right? There might not be a name for the fraction of centimeter that you are measuring, but it exists. Yes? My body is not sliced up like a salami. Everybody understand?
Yep.
Okay, good. Discrete is counted. So continuous data is any data that can take any values. And the difference I like to say is continuous data is measured. Does everybody understand the difference between counting and measuring? Everybody? I can count you guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? That's counting. Measuring, how far is Joseph to me? Some amount of meters, some amount of centimeters, some amount of millimeters, some amount of nanometers, some amount of picometers, some amount of so on, so on, and so on. Yes? So that is measured. Everybody cool? Now, how does that apply to a relation? So we can talk about the single piece of data in a relation, but now we got to talk about the whole relation. So once we've got a relation, we've got inputs and outputs, yes? So let's use the two things that I did. Or the two things we were talking about. Kids and... No, that won't work. Let's give you another 2 examples. My age and my height. Is that discrete or continuous if I'm comparing the two?
Continuous.
Why?
It doesn't stop.
Any age between.
I always have an age
You always have
and I always have a height. Okay? Now, compare my age to my number of children. Discrete or continuous? Discrete. Why?
you don't have half a child.
Because I didn't have a child until I was 20. And then I didn't have another one until 2 years later. And then I don't have any more. So do I always have an age? But is my domain value, the number of children, continuous or is it restricted to certain values?
Restricted.
Everybody got it? Okay.
Why did you put out the 20s?
Because I can't remember how old I was when I had my first child.
Oh,
I was gonna say, I was like, secret, huh?
He was born in 2004. So I was 29.
Nice.
Okay, so he's
Well, that doesn't really work, though, because we weren't born in the same month.
so he's 14.
I was 29 and a half. No, I wasn't. May, June, July, August. I was 29 and a third.
Wow.
29 and a third. Then when my daughter came along, I was 31 and a half.
So he's 14 grade 9.
Yes. Is everybody good? All right, let's see if you're really good or if you're big liars. Given this comparison, step 1, dependent and independent variables. First, I got to decide what are the variables. Variables are anything I can count. What are the two variables there? Speed of sound is one variable. Air temperature is the other variable. Awesome. Possums. Which one is the IV? Which one is the DV? Independent and dependent. One of those depends on the other one. Now you have to think about this because you're not physicists. It's a fun word to say.
At a constant pressure, the speed of sound in air is related
Air temperature is IV and
So
speed of sound.
Joseph says the temperature is the IV and the speed is the DV. The only other option is reversing that, correct? So, how many people are on Joseph's team? 1, 2, 3, 4, 5, 6, 7, 8. How many people are on the other team? Because nobody said a name. Oh, 8 out of 30. Wow, it's getting better.
seems that our brains
Why don't all of you guys just say, you know what, government, you just take over and run the show. We don't even care anymore. Oh, wait, that's a dictatorship, and everybody hates that. But nobody will vote. What a conundrum. So, which is it?
black.
Of course it's Joseph's. Why? Joseph said it, so it's right. Joseph's only getting like 89%. That means he's only right 89 out of every 100 times.
Expose him. Hey, you're acting like that's a bad mark.
You don't care.
It's not like you're getting 50.
Are we voting with Joseph? Great. Okay. I'm going to tell you he's right. Why?
Because
It says
the speed
it's
depends
like
on the air
affected
temperature.
by the air.
Of course the speed depends on the air temperature. Why?
Because the air,
It's affected
the
by
more
Okay.
air temperature.
I'm going to ask you all to do something that is 100% impossible. It's never occurred in the 23 years I've been teaching. I need you to not make a sound for 10 seconds. Everybody ready? Everybody ready? I'm going to nod, and that's when the 10 seconds starts. Everybody ready? Almost.
Are you serious?
Almost. The class this morning dropped a pencil. He was holding it and playing with it and dropped it 3 seconds in. Not bad. You guys got close.
Oh, what did we get? 8?
Was there an air temperature?
No.
Yes, there was. The air has a temperature right now. Was there sound passing through it? No. So which one is independent?
The air
Temperature. Second question. Is this comparison discrete or continuous?
Continuous.
It is continuous. Why?
Because it doesn't stop. You don't.
For every temp,
Oh, I see.
there's a speed. I'm talking to you right now, yes? Sound is hitting your eardrums, yes? Your eardrums are vibrating, the sound waves are going down into your cochlea, and you are using that to, and then your brain is saying, these are words that are being spoken,
Yeah.
right?
That's so weird.
Now, let's pretend that the temperature changes. It gets really, really hot in here. What's going to happen to...
You're not using air to speak. You're not using your
It's silly, right? I'm talking right now. It gets suddenly very hot in here, and now the sound...
That doesn't make sense.
Of course the sound doesn't stop coming out of my mouth
Oh, okay.
if it gets hot.
I thought you were being serious.
Okay.
I got really
Okay? Everybody good? All right, let's try the second one. What are the two variables?
Vitamin C and age.
The dose and the age. What's the IV? What's the DV? IV is age. DV is dose. Why? Older she gets, the more vitamins she needs. Okay. Any other way you could describe it? What if I was an old woman who chose not to take vitamin C?
No.
Would I still have an age?
Yeah.
Easy. So what's the independent variable?
Age.
Age. Now, this is where it gets a little hazy. We've already talked about age, haven't we? Age, is age continuous or discrete? Continuous, because you always have an age. Is the dose of vitamin C discrete or continuous? Discrete. Because you cannot get out a laser and cut off a little tiny bit of the pill every single day, can you?
Age only changes.
So, is the relation discrete or continuous? The relation is discrete. Because even though my age is continuous,
It doesn't change every day.
yes it does. You get older every single day.
Every single
Second, you are how many seconds? I know, I'm wasting seconds right now. Here, let's have some fun with seconds just for fun. How many people in this room, how many of you feel, and I may have done this gag already, but we're going to do it anyway. How many of you people feel that you are 1 million, it's a big number, 1 million seconds old? How many of you feel, you all know you're 14 or 15 years old. I want to know, are you 1 million seconds old? Yes or no? Okay. What's the next big number after million? Billion. How many of you feel you're 1 billion seconds old? All right, I will tell you this. Every single one of you is 1 million seconds old. You were 1 million seconds old when you turned 11 days.
What?
11 days old, you had lived 1 million seconds. Guess how many people in the room are 1 billion seconds old? One. Me. Because you turn 1 billion when you're 37. So that's a little number for you guys to remember. When you hear governments talking about spending billions of dollars on something, remember this. 1 million seconds, 11 days. 1 billion seconds, 37 years. So when you hear doctor or government say, oh, it was only $1 billion, I'm 1 billion seconds old. That's 37. I will be lucky to live to 2 billion seconds old. 74.
Age. The number of your age
Now.
changes once a year.
Yes? Huh? 473 million seconds old. Yeah. Whatever you need, sister. All right. So this is discrete. Why? Because my range is restricted, isn't it? Right? I can't take 1/365th of a pill when I turn 1 day older. Everybody understand? All right. Next. What are the variables?
Cans and cost.
Cans is a variable, cost is a variable. What's the IV? What's the DV?
The independent variable is the cost.
So the cans.
Oh wait, yeah.
Cans, cost. The cost depends on the cans. Discrete or continuous?
Continuous.
Oh, no, discrete.
Discrete.
You're not buying half a can.
You can't buy half a can. You cannot go to Safeway. Excuse me, sir, I am very thirsty. I would like a can of your finest orange juice. Here you are, sir. Thank you very much. How much is that? That's $1.20. Glug, 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 glug. I am done. Here you are. I have drank 3 ounces of the 12-ounce can. It costs $1.20. I have drank a quarter of it. Therefore, here is 30 cents. You feel free to sell that other 3/4 to the next person. Does that happen? No, it doesn't. Both of those are discrete, aren't they? All right. And lastly, what are the variables? Altitude, it can change. I can go up and down. Temperature can change. IV, DV. I haven't said if he's right.
Yeah, but Zach did.
Of course he's right. Why? The higher up you go, the colder it gets. Look at Mount Baker. It's snowy all year round. Why? Because it's 14,000 feet in the air. Now, we're not done. Discrete or continuous?
Continuous. The
Continuous.
higher you go, the colder it gets.
Why is it continuous?
The higher you go, the colder it gets.
Is there always an altitude?
Yes.
Is there always a temperature at that altitude? Right? Right now, my head is right here. Right? If I go up to the top of Mount Baker, do I pass through all those temperatures and all those heights?
Yes.
Yes. Do I teleport up there? No. So it is continuous. Is everybody good?
Wouldn't it also be because the higher you go, the colder it gets? That's why it makes it continuous. Because it keeps
No. It's a relationship between input and output. All right, listen up. Listen up. Listen up.
Listen up. Okay.
I have already told you that the book is printed poorly. Your work for this lecture is back. It's like 160 to 162 or whatever. But listen to me. Okay? Whatever it is.